Hello everyone, welcome back to this calm space. Today we are going to talk about galaxy. We are taught that the universe is expanding, that every galaxy is drifting away from every other galaxy into a lonely isolation. But this story is incomplete. While it is true that the fabric of space is stretching, carrying the islands of light further apart into the deep, there is another motion hidden underneath that general expansion. It is a motion that went unnoticed for decades, because it defies the standard logic of the Big Bang. We are not just drifting aimlessly into the void. We are being summoned. If you were to look at a three-dimensional map of our local universe, treating the galaxies like dust motes suspended in a sunbeam, you would not see a chaotic scattering. Instead, you would see a flow. Thousands of galaxies, including our own Milky Way, are streaming in a single coherent direction, moving like a river finding its way to the sea. This is not a collision course with destruction. It is a return to the source. Think of it not as a crash, but as a vast cosmic watershed, where gravity acts like the slope of a mountain, guiding the water down into a deep, silent basin. The universe pushes things apart with dark energy, yet something stronger, something massive and ancient, is pulling us together. For years, astronomers were baffled by this movement. They measured the speed and found it to be impossible to explain by the visible matter alone. We are moving too fast, and the destination is hidden behind a thick curtain of stars. Tonight, we are going to follow this river upstream. We are going to trace the invisible current that holds our galaxy in its grip. And we are going to understand why, in a universe defined by isolation, we are actually part of a massive congregating family. By the end of this journey, you will understand that we are not lost in the dark. We are simply heading home. To understand this journey, we must first understand the water in which we swim. For most of the 20th century, the dominant view of the cosmos was one of uniform expansion, a concept known as the Hubble flow. Imagine a loaf of raisin bread rising in a warm oven. As the dough expands, every raisin moves away from every other raisin. From the perspective of any single raisin, it looks as if the entire universe is fleeing. This is the baseline reality of our existence. Space itself is being created between the galaxies, pushing the great Andromeda and the distant clusters away from us, stretching the wavelength of their light into the red part of the spectrum. That is why, for a long time, we believed that our destiny was solitary. If gravity is the only force that binds, and expansion is the force that separates, then eventually expansion should win. The galaxies should drift so far apart that the night sky becomes empty, leaving us alone with our own dying stars. But when astronomers began to measure the movement of the Milky Way with extreme precision, they found a discrepancy, a ghost in the machine. When we subtract the rotation of the Earth, which spins at 1,000 miles per hour, and we subtract the orbit of the Earth around the Sun, which carries us at 67,000 miles per hour, and we even subtract the rotation of the Sun around the center of the Milky Way, a vector remains. There is a leftover speed that should not be there. It is called the peculiar velocity. In the language of astrophysics, peculiar does not mean strange, it means specific. It means that after you account for the general expansion of the universe, our galaxy has a specific directional speed of its own. We are moving at 600 kilometers per second toward the constellation Centaurus. That is 1.3 million miles per hour. To put that into perspective, in the time it takes you to take a single slow breath, our entire solar system has traveled 400 miles closer to this mysterious point. It is a speed that creates a kind of wind in the cosmos. When we look at the oldest light in the universe, the cosmic microwave background, we see a dipole, a distinct difference in temperature between the sky in front of us and the sky behind us. The light ahead is slightly bluer and warmer, compressed by our motion, while the light behind us is slightly redder and cooler, stretched out as we leave it behind. This is the cosmic equivalent of driving through a rainstorm. The rain hits the front windshield harder than the back. We are plowing through the radiation of the early universe, heading toward a gravitational valley so immense that it is pulling not just us, but millions of other galaxies along with it. It helps astronomers understand the scale of this structure when we compare it to a river system on Earth. If the expansion of the universe is the land spreading out, then gravity is the topography, the hills and the valleys that direct the flow of water. We are essentially swimming upstream against the expansion. The universe is trying to blow us apart, but the gravity of this distant region is reeling us in with a force that defies the dark energy pushing against it. This realization changes our perception of our place in the cosmos. We are often told that we are insignificant, just a tiny data point on a rocky sphere, worrying about how to boil water slightly more efficiently to generate electricity, while the universe ignores us. And while we are small, we are not static. We are participants in a grand migration. The Milky Way is like a leaf caught in a majestic, slow-moving current. We are not tumbling through chaos. We are sliding along a gravitational streamline that was carved out billions of years ago, shortly after the first stars ignited. However, identifying the speed was the easy part. Identifying the source of the pull was the challenge that haunted astronomers for decades. You might wonder, if something is massive enough to drag a galaxy spanning 100,000 light-years across the void at such incredible speeds, surely we should be able to see it. It should be the brightest, most obvious object in the night sky. It should be a beacon. But when we looked in the direction of our movement, toward the constellations of Hydra and Centaurus, we saw nothing but dust. This is the great irony of our position in the galaxy. We live in the suburbs of the Milky Way, out in the spiral arms, which is a quiet and safe place for life to evolve. But our view of the universe is blocked by our own home. The center of our galaxy is filled with thick clouds of gas, dust, and bright stars that form a dense band across the sky, what we call the zone of avoidance. For the radio astronomers listening to the sky in the 1970s and 80s, this was the era of the Seven Samurai, a collaboration of scientists on a quest to map the unmappable. They knew the gravity was there. They could feel the tug in the data. The math insisted that a mass equivalent to tens of thousands of galaxies must be hiding behind that curtain of diamond dust. But their optical telescopes were useless. Trying to see the Great Attractor through the plane of the Milky Way is like trying to see the horizon while standing in the middle of a thick fog bank. The visible light is scattered and absorbed, leaving us blind to the very thing that is controlling our destiny. It is a reminder that our perspective is always limited by our biology and our location. We are trapped inside the very thing we are trying to study. But just as we learn to see in the dark using infrared light, we eventually learn to peer through the dust. We realize that while visible light is blocked by the fog of the galaxy, X-rays and radio waves can pass through almost unimpeded. When we finally looked through the veil, peering into the zone of avoidance, with these new eyes, we did not see a single monster object. We did not see a supermassive black hole eating the universe, nor did we see a solid wall of matter. Instead, we saw a valley. We saw a vast, sprawling region where galaxies were clustered together not in a tight knot, but in a beautiful, elongated filament structure. It was less like a drain and more like a harbor, a gathering place where the filaments of the cosmic web intersect. This region is difficult to conceptualize because it is not a thing in the way a planet or a star is a thing. Imagine a sheet of rubber stretched out, representing the fabric of space. If you place a bowling ball in the center, it creates a dip. Now imagine placing thousands of marbles in a wide, shallow depression that spans hundreds of millions of light years. That is the Great Attractor. It is a concentration of mass so diffuse that you could fly a spaceship through it and never hit a star, yet so massive in total that it bends the flow of the entire local universe. This discovery led us to redefine our address. We used to think we lived in the Virgo supercluster, a modest collection of galaxies. But by mapping these flows, by tracing the streamlines of thousands of galaxies moving toward this attractor, we realize that Virgo is just an appendage. We are actually part of something much larger. We call this larger structure Laniakea. In the Hawaiian language, Laniakea means immeasurable heaven. It is a fitting name for a structure that spans 520 million light-years and contains the mass of 100 million billion suns. Laniakea is our true home. It is the watershed of our local universe. Just as rain falling on the continental divide flows into either the Pacific or the Atlantic, galaxies in our region of the universe flow into Laniakea. Every galaxy inside this boundary, including the Milky Way, Andromeda, and thousands of others, is sliding down the gravitational slope toward the Great Attractor at its heart. We are not isolated islands. We are droplets of water in a river that is 500 million light-years wide, and like a river, the flow is smooth, continuous, and silent. There is no turbulence here, only the slow, majestic slide of galaxies through the dark, guided by the invisible hand of gravity. But even Laniakea is moving. The basin itself is sliding across the table of the universe. As we map the flow of our own supercluster, we began to notice that the Great Attractor was not the end of the line. It was merely a tributary. The river continues. The pull we feel is not just from the mass in front of us, but from something even further away, something deeper in the cosmic ocean. It turns out that the universe is a hierarchy of flows. We are falling into the Great Attractor, but the Great Attractor is falling into something else. It is a mystery behind a mystery. Layers of gravity folding over one another like sheets of silk. To understand where we are truly going, we have to look beyond the basin, out into the darker, deeper waters, where the Shapley concentration lies waiting. But before we travel that far, we must understand that our movement is not just about being pulled. We are also being pushed. Strategy block. Audience phrases used. Primitive eyes, cosmic cage, the void, data point, quiet chaos, viral hooks, the hidden wall, curiosity, the seven samurai, production script. To understand why this destination remained hidden from us for so long, we must first accept a strange irony about our place in the cosmos. We are attempting to map the universe from the inside of a cage. This cage is not made of iron or steel, but of light and dust, a dense glowing fog that wraps around our solar system and blocks our view of the deep universe beyond. For decades, astronomers knew that something massive was out there. They could measure the speed of our galaxy, a velocity that defied the logic of a random drift. Yet when they pointed their telescopes toward the source of this gravity, it is like trying to see the horizon while standing in the middle of a dense forest. The trees that surround you are beautiful, but they prevent you from seeing the mountain that lies beyond them. This blinded region of the sky is known by a name that sounds almost forbidden: the zone of avoidance. It covers nearly 20% of our night sky, a vast, obscure ribbon where the stars of our own galaxy are packed so tightly, and the clouds of interstellar dust are so thick, that visible light cannot pass through. For the better part of the 20th century, this zone was a blank space on our maps, a here be dragons of the modern era, where our vision simply ended. The dust that creates this curtain is not the dust we find under a bed or on a bookshelf. It is cosmic soot, tiny grains of carbon and silicon forged in the cooling atmospheres of dying stars, drifting together to form great majestic clouds. While these clouds are the nurseries where new stars are born, acting as the fertile soil of the galaxy, they are also effective barriers. They scatter the blue light of distant galaxies, absorbing the visual information of the universe before it can reach our primitive eyes. That is why for generations we felt the pull of the Great Attractor before we ever saw it. We were like sailors on a ship in heavy fog, feeling the tide pull us toward a shore we could not see, sensing the presence of a massive continent purely by the way the water moved beneath our hull. The gravity traveled through the dust, for gravity cannot be blocked, but the light did not. This mystery persisted until a group of astronomers, who would later be nicknamed the Seven Samurai, decided to look at the problem differently. They realized that if the wall of dust was blocking visible light, they needed to change the way they looked at the sky. They needed to stop looking with their eyes and start listening with their instruments, tuning their receivers to the longer, slower wavelengths of infrared light and radio waves. Infrared light is the ghost that walks through walls. Its waves are long enough to slip between the grains of cosmic dust without being scattered, carrying the secrets of the far universe through the zone of avoidance and onto our sensors. When the Seven Samurai finally pierced this veil in the late 1980s, the blank space on the map began to fill with light. They did not see a single monstrous object waiting in the dark. Instead, they saw a landscape. Through the clearing mist of the Milky Way, thousands of previously invisible galaxies emerged, not scattered randomly, but clustered together in a great dense structure. It was a valley of light, a basin where gravity had been collecting matter for billions of years. This was the first true glimpse of the Great Attractor. It was not a black hole, and it was not a singular, devouring beast. Just as a river delta collects the silt and water from 1,000 different streams, this region of space was collecting the galaxies of our local universe, drawing them in to huddle together against the expanding dark. The zone of avoidance had hidden this bustling metropolis from us, leaving us in a quiet isolation, unaware that we were part of such a vast migration. But now that the curtain has been pulled back, we can see the architecture of our journey. We can see that the dust of our own home was merely hiding the grandeur of our destination. Yet even as we map this new supercluster, measuring the positions of the Norma cluster and the heavy walls of galaxies that define it, the numbers still did not quite add up. The Great Attractor was massive, containing the mass of tens of thousands of Milky Ways, but it was not massive enough to account for the sheer speed at which we are moving. The river was flowing too fast for the size of the delta. This suggests that the Great Attractor is not the end of the river, but merely a bend in it. It is a significant waypoint, a heavy, glowing knot in the cosmic web. But the true source of the current, the ultimate ocean that is summoning us, lies even deeper in the void, hidden behind yet another layer of distance and time. Strategy block, audience phrases used: data point, primitive eyes, the void, quiet chaos, viral hooks, the intellectual contradiction, expansion versus attraction, the river production script, 0. The hook, we are taught that the universe is expanding, that every galaxy is drifting away from every other galaxy. For decades, the standard model of cosmology has painted a picture of a universe that is stretching apart, where the space between worlds grows wider with every passing second, pushing us into a cold, solitary future. It is a logical, mathematical certainty. But when we look closer at the movement of our own Milky Way, the math does not quite add up. If the universe were simply expanding, we should be drifting aimlessly, like a leaf on a growing pond. Yet we are not drifting. We are moving with purpose. When astronomers subtract the rotation of the Earth, the orbit of the Sun, and the spin of the galaxy itself, a ghost remains in the data, a specific directional speed known as a peculiar velocity. We are moving at 600 kilometers per second, a speed that defies the general expansion towards a specific point in the southern sky. We are not just floating in the void, we are being summoned. To our primitive eyes, the night sky looks static, a frozen tapestry of light. But if you could see gravity the way you see light, the sky would look like a turbulent ocean. You would see that our galaxy is just one tiny data point in a massive river of matter, caught in a current that spans hundreds of millions of light years. We are swimming upstream, fighting the expansion of the universe, drawn toward a gravitational anomaly so massive that it is pulling over 100,000 galaxies toward it. This is the Great Attractor. Now, the name itself sounds ominous, like a monster waiting in the dark. But rest assured, this is not a collision course with destruction. It is a return to the source. Think of it not as a crash, but as a river finding the sea. The universe may be pushing things apart with dark energy, but gravity, the ancient silent sculptor of the cosmos, is still pulling us together, weaving the strands of the cosmic web into a grand design. Tonight, we are going to follow this current. We will peel back the layers of dust that have hidden this giant from our view for centuries. We will map the invisible valleys of gravity that guide our journey. And by the end of this, you will understand that we are not lost in a random chaotic explosion. We are part of a flow, a vast, silent migration toward a home we have never seen, drifting through the quiet chaos of the deep universe. The current is strong, the direction is clear, and the journey begins now. Strategy block, audience phrases used, data point, helps astronomers understand the void, cosmic cage, primitive eyes, viral hooks, the intellectual contradiction, expansion versus motion, the Doppler shift. For the better part of a century, the standard map of our reality has been defined by a single overwhelming concept. We are taught that the universe is like a balloon being inflated, where every point on the surface moves away from every other point. In this version of the story, there is no center and no edge, only a vast uniform stretching that condemns every galaxy to eventually drift alone in the deep. It is a lonely model. It suggests that gravity has lost the war against dark energy, and that we are destined for isolation. But nature rarely adheres to the simple stories we tell ourselves. When astronomers began to map the movement of the local universe with greater precision, they noticed a subtle violation of this rule. If the universe were simply expanding, everything should be receding from us uniformly. Yet when we look at the oldest light in the cosmos, the cosmic microwave background, we see a ghost in the machine. This background radiation, the afterglow of the Big Bang, should be the same temperature in every direction, a perfect freezing snapshot of the early universe. But it is not. In one direction, toward the constellation of Leo, the universe looks slightly warmer than it should. In the opposite direction, toward Aquarius, it looks slightly cooler. To our primitive eyes, this temperature difference is invisible, less than a fraction of a degree, but to a spectrometer, it is a glaring signal. It is the cosmic equivalent of wind hitting your face. This phenomenon helps astronomers understand a fundamental truth about our place in the void. We are not sitting still. The temperature difference is a Doppler shift, created because our entire galaxy is moving through the fabric of space at an immense velocity. We are crashing into the photons ahead of us, making them appear hotter and bluer, while leaving the photons behind us to stretch out and cool down. To find our true speed, we must first subtract the noise of our own local dance. We have to mathematically remove the rotation of the Earth, which spins at 1,000 miles per hour. We must subtract the orbit of the Earth around the Sun, and the Sun's orbit around the center of the Milky Way, which carries us at nearly 500,000 miles per hour. When we strip away these local motions, peeling back the layers of our own cosmic cage, a single undeniable vector remains. We are left with a peculiar velocity. This is the scientific term for motion that defies the general flow of the universe. While the rest of the cosmos expands outward, the Milky Way and its neighbors are swimming upstream. We are moving at 600 kilometers per second, over 1.3 million miles per hour, toward a specific point in the southern sky, near the constellation Centaurus. This is not a random drift. Randomness cancels itself out over large scales. This is a coordinated migration. If you were to look at a three-dimensional map of our corner of the universe, treating every galaxy as a simple data point, you would see that we are not alone in this journey. Thousands of galaxies spanning hundreds of millions of light years are caught in the same current. We are all flowing toward the same mysterious basin, a gravitational valley so massive that it overpowers the expansion of the universe itself. We call this flow a river of gravity. Just as rain falling on a continental divide must eventually find its way to the ocean, galaxies in our sector of the universe are sliding down a gravitational slope. We are falling, but we are falling together, caught in a stream that is older than the Earth itself. And to understand where we are going, we must understand what is hiding behind the dust of our own galaxy, blocking our view of the destination. Strategy block, audience phrases used, data point, primitive eyes, deep time, cosmic cage, viral hooks, the intellectual contradiction, expansion versus motion, the safe speed reframe, production script. To understand this movement, we must first look at the map of the universe as we were taught to see it. For decades, the standard model of cosmology has been defined by the Hubble flow, a general rule stating that the universe is expanding and consequently every galaxy is drifting away from every other galaxy. If you were to look at the cosmos from a God's eye view, it would resemble a loaf of raisin bread rising in an oven. As the dough expands, every raisin moves further apart from its neighbors, not because they are moving, but because the space between them is stretching. This is the baseline drift of existence. It is a lonely, uniform expansion into the void. But when astronomers began to measure the temperature of the universe in the 1970s, looking at the oldest light in existence, the cosmic microwave background, they found a contradiction that the Hubble flow could not explain. If we were simply floating in an expanding balloon, the background heat of the universe should look identical in every direction. It should be a perfect uniform static. But it is not. When we point our primitive eyes toward the constellation Leo, the cosmos looks slightly warmer than average. When we look in the opposite direction toward Aquarius, it looks slightly cooler. This is known as a dipole, a Doppler shift caused not by the universe changing, but by our own motion through it. We are crashing into the photons ahead of us, turning them blue and hot, while leaving the photons behind us to stretch out into the red and cold. It is the cosmic equivalent of wind hitting your face as you stick your head out of a moving car window. We are not sitting still. We are driving. To find our true speed, we have to do a massive calculation of subtraction. First, we subtract the rotation of the Earth, which spins us at 1,000 miles per hour. Then we subtract the orbit of the Earth around the Sun, a journey of 67,000 miles per hour. Finally, we subtract the rotation of the Milky Way itself, which spins on its axis at a dizzying 500,000 miles per hour. When all these local movements are stripped away, a single undeniable vector remains. We are moving at 600 kilometers per second. That is 1.3 million miles per hour, directed straight toward the constellation Centaurus. In the language of astrophysics, this is called our peculiar velocity. It is peculiar because it defies the general expansion. While the universe tries to push us apart, something stronger is pulling us in. Think of the Hubble flow as the current of a river moving downstream, carrying leaves and silt toward the ocean. Our galaxy is a salmon swimming upstream, fighting the current with a specific powered determination. We are not drifting randomly, we are being summoned. And a force capable of accelerating a galaxy of 100 billion stars to such incredible speeds implies a gravitational source of immense magnitude, a great attractor that acts as a harbor for the wayward ships of the local universe. Strategy block, audience phrases used, primitive eyes, cosmic cage, data point, the void, sleepy science, viral hooks, the irony of visibility, seeing far but not near, the forbidden zone naming convention, production script. But for decades, this gravitational harbor remained a ghost story in the data. We could measure the speed of our galaxy, and we could calculate the immense mass required to generate such a pull. Yet when astronomers turned their telescopes toward the source, they saw nothing but a wall of darkness. It is one of the profound ironies of our position in the cosmos that we can capture light from the edge of the observable universe, 13 billion light years away. Yet we remained blind to the massive structure sitting right in our own backyard. This blindness is not due to a lack of technology, but rather a consequence of our location. We reside inside the disk of the Milky Way, a vast, flat spiral of stars, gas, and interstellar dust. When we look up at the night sky away from this disk, our view is clear, opening out into the deep void where distant galaxies drift like islands in a dark sea. However, when we try to look through the disk toward the center of our own galaxy, our view is obstructed by a thick, chaotic fog of matter. Astronomers call this region the zone of avoidance. It is a dramatic name for what is essentially a dusty windowpane. For the better part of the 20th century, this zone comprised roughly 20% of the entire sky, a blank patch on our star charts, where no data could be gathered. It was a forbidden sector, not because of any cosmic law, but because our primitive eyes were unable to pierce the veil of our own home. Imagine standing in a dense forest on a foggy night. You might see the distant lights of a city above the tree line, but if you try to look horizontally through the trunks and the mist, your vision is halted after only a few yards. This is the zone of avoidance. The dust between the stars is not like the dust under a bed. It consists of microscopic grains of carbon and silicates, smoke-like particles that are incredibly efficient at scattering visible light. They act as a curtain of diamond dust, absorbing the optical wavelengths that our eyes and early telescopes relied upon, hiding everything that lay behind them. For the astronomers of the 1970s and 80s, this was a source of quiet professional agony. They knew the Great Attractor was there. The mathematics demanded it. The peculiar velocity of the Milky Way, that 600 km/s slide, pointed directly into the heart of this opaque fog. It was as if we were sliding down a gentle hill in the dark. We could feel the slope, we could measure our acceleration, but we could not see the valley floor waiting below. This era gave rise to a group of researchers known as the Seven Samurai. It sounds like a title from a storybook, but in the annals of astrophysics, it refers to a specific collaboration of scientists who dedicated themselves to mapping the unmappable. They spent years measuring the distances and motions of every galaxy they could see on the edges of the zone of avoidance, trying to extrapolate the shape of the ghost hiding in the center. They were detectives working the edges of a crime scene where the body was missing, tracing the footprints of gravity to outline the invisible giant. It helps astronomers understand the patience required in this field. They were building a map of a room they could not enter, using only the shadows cast on the walls. They theorized that the Great Attractor was not a single monstrous object, but a concentration of galaxies so dense that their combined gravity formed a basin, a low point in the fabric of space-time, where all local matter was naturally pooling. But without visual confirmation, it remained a theory, a mathematical dragon hidden behind a wall of smoke. The breakthrough required a shift in how we perceive the universe. We had to stop looking with the eyes we were born with and start looking with the eyes we built. Visible light is easily blocked by dust because the wavelength of the light is roughly the same size as the dust grains, causing it to bounce off. But infrared light has a longer wavelength. It is a ghost that can walk through walls. To an infrared telescope, the thick fog of the Milky Way becomes translucent, a thin mist that reveals the warm, glowing hearts of the galaxies hiding behind it. When technology finally allowed us to peer into the zone of avoidance with infrared instruments, the wall dissolved. The curtain of diamond dust was pulled back, and for the first time in human history, we saw the landscape that had been pulling us for billions of years. We did not see a singular, terrifying object. We did not see a black hole of impossible size, nor a tear in the universe. Instead, we saw a valley. We saw a vast, glowing architecture of light. Thousands of galaxies, previously hidden by the dust of our own spiral arms, were revealed to be clustered together in a magnificent, dense formation. It was a metropolis of stars, a grand central station where the filaments of the cosmic web knotted together. This region, now known as the Norma Cluster, sits at the heart of the Great Attractor. It is a region where the universe is old and heavy, where galaxies have had time to drift together and settle into a deep gravitational embrace. The zone of avoidance had hidden a supercluster of immense beauty. It was a reminder that our perspective is always limited by our position. We had feared a monster in the dark simply because we could not see the harbor. The gravity that pulls us is not a predator dragging us into a cave. It is the collective mass of millions of other worlds, a gathering of galaxies that forms the gravitational center of our local universe. This revelation changed our understanding of our place in the cosmos. We realized that the Milky Way is not an isolated island, it is part of a flow. Just as water flows from the mountains to the sea, following the contours of the land, our galaxy is flowing along the contours of gravity, sliding down the invisible slopes of space-time toward this newly revealed basin. The zone of avoidance was never a barrier to our movement. It was only a barrier to our understanding. And as we mapped this hidden region, we began to see that the Great Attractor was just one part of a much larger story. The Norma cluster is massive, yes. It contains the mass of quadrillions of suns. But even as we identified it, we noticed something strange. The data points didn't quite line up. The pull of the Norma cluster was strong, but it wasn't strong enough to account for the full speed of our journey. We were moving too fast. It was as if we had found the river, but we had not yet found the ocean. The Great Attractor was pulling us, but something else, something even larger and more distant, was pulling the Great Attractor itself. The veil had been lifted, only to reveal another deeper mystery standing behind it. We had looked through the dust and found a valley, but beyond that valley, the landscape continued to slope downward, descending into a region of space so vast that it defies the standard definitions of a supercluster. We call this larger structure Laniakea, and to understand it, we must stop thinking of the universe as a collection of objects and start thinking of it as a collection of flows. We must move from the static maps of the past to the fluid dynamics of the future. The zone of avoidance is no longer a blind spot. It is the gateway to the watershed of the local universe. Strategy block. Audience phrases used: data point, deep time, the void, cosmic cage, absorb and hope, viral hooks, cosmic vertigo, scale of Laniakea, domestic anchoring, watershed, rain metaphor, production script. To visualize this new map, we must leave the vacuum of space for a moment and return to the familiar gravity of Earth. Imagine you are standing on the very peak of a great mountain range, a continental divide where the rock pierces the clouds. If a storm breaks and rain begins to fall, the water that lands a few inches to your left might flow into a river that eventually drains into the Pacific Ocean. The water that lands a few inches to your right, however, might begin a journey toward the Atlantic. These two drops of rain, separated by only a breath of distance at the start, are destined for entirely different fates, pulled by the invisible topography of the landscape into vast, separate basins. This is exactly how the universe is arranged. We tend to think of galaxies as islands scattered randomly in a dark ocean, but they are actually droplets of light moving along the slopes of invisible gravitational mountains. There are regions in the cosmos where the pull of gravity splits, creating cosmic watersheds. Everything on one side of the divide flows toward a central attractor, while everything on the other side drifts away toward a different destiny. For decades, astronomers struggled to define where our local cluster of galaxies ended, and the next one began. The boundaries were fuzzy, defined only by how close things looked to one another. But in 2014, a team led by astronomer R. Brent Tully changed the definition of a map. They stopped looking at where galaxies were and started looking at where they were going. By tracing the velocities of thousands of galaxies, subtracting the expansion of the universe, they found the ridgelines of our watershed. They named this structure Laniakea. It is a word borrowed from the Hawaiian language, meaning immeasurable heaven. It is a fitting title for a home so vast that light itself would need 520 million years. Within this boundary, There are 100,000 galaxies, each one a collection of billions of stars, planets, and quiet moons. And yet, despite this immense scale, every single one of them is sliding down the same gravitational slope. The Milky Way, Andromeda, and all our neighbors are not independent travelers. We are part of a synchronized flow, a great river of 100 million billion suns, all drifting toward the same valley in the dark. This redefinition helps astronomers understand that we are not just residents of a galaxy, or even a local group. We are citizens of a supercluster defined not by its walls, but by its current. If you were to float outside of Laniakea and look down, you would not see a solid object. You would see a delicate lace of light, a web of filaments stretching across the void, with galaxies like dust motes caught in a stream, all converging toward a central point that acts as the heart of the flow. It is humbling to realize that our position in the universe is defined by this movement. We are a data point in a flowchart that spans 500 million light years. The gravity that guides us is gentle, but it is absolute. It has been acting on us since the early universe, a subtle hand on the back of the galaxy, guiding us through the deep time of cosmic history. However, the discovery of Laniakea brought with it a deeper mystery. We found the edges of our swimming pool, and we mapped the current carrying us. But when we looked at the speed of Laniakea itself, we noticed something strange. The entire basin, this structure of 100,000 galaxies, is not stationary. It is moving. The watershed itself is sliding across the table of the universe. We thought Laniakea was the answer, the final container for our galaxy. But it turns out that even this immeasurable heaven is being pulled by something else. Something far larger and more distant than we had ever imagined. The river we are in flows into an even greater ocean, and the current is picking up speed. Strategy block, audience phrases used: the void, data point, cosmic cage, absorb and hope, viral hooks, the invisible push, contradiction, the empty room analogy, domestic anchoring, domestic anchoring, domestic anchoring, domestic anchoring, domestic anchoring, production script. We often make the mistake of thinking that gravity is the only sculptor of the universe, a force that strictly pulls, gathers, and binds. We assume that because we are moving so fast toward the Centaurus constellation, the answer must lie entirely in the mass that is summoning us. But this story of attraction is only half of the picture. To understand the true nature of our journey, we must stop looking forward at the destination, and for a moment, look behind us into the dark. There is something pushing us. In 2017, astronomers mapping the flows of the local universe discovered a region of space that seemed to defy the standard rules of cosmic architecture. Directly opposite the Great Attractor, sitting behind our Milky Way, like a vast, silent cavern, is a region known as the Dipole Repeller. It is a name that sounds active, perhaps even violent, suggesting a force that shoves galaxies away. But in the quiet physics of the deep cosmos, the reality is far more subtle, and in a way more peaceful. The Dipole Repeller is not a machine or a monster. It is a void. It is a profound emptiness in the fabric of the universe, a region where the density of galaxies is far lower than the cosmic average. You might wonder how an empty space can push anything. Given that gravity is an attractive force, the answer lies in the balance of the crowded room. Imagine you are standing in a crowded hall, packed with people on one side and completely empty on the other. The crowd represents the Great Attractor, a dense concentration of mass pulling you in with its gravity. The empty side is the Dipole Repeller. Because the void has so little mass, its gravitational pull is weak, almost non-existent. The dense side pulls you strongly, and the empty side does not pull you at all. To a data point floating in the middle, to us, this lack of resistance from the void feels exactly like a push. We are not just falling toward the ocean. We are sliding down a hill, away from the empty peak, and into the deep valley. This realization changes how we perceive our place in the Laniakea supercluster. We are caught in a cosmic flow that is dictated as much by what is missing as by what is present. The dipole repeller acts as a high-pressure system in our galactic weather map, clearing the skies behind us and funneling the Milky Way, Andromeda, and all our neighbors along a specific path. It is a wind at our backs, a gentle, invisible hand that has been guiding the trajectory of our solar system for billions of years. It is strange to think that emptiness can be a force. We are taught to fear the void, to see it as a lonely, cold expanse. But here, in the mechanics of the great flow, the void is helpful. It is the silence that allows the music to be heard. It is the open space that allows the river to run. Without this vast region of nothingness behind us, our journey would be slower, more chaotic, perhaps lacking the clear direction that currently defines our drift through the cosmos. As we move away from this region of underdensity, we are effectively leaving the cosmic highlands. The universe is seeking equilibrium, draining matter away from the empty spaces and pooling it into the dense clusters. We are simply a droplet in that drainage, obeying the topography of gravity that was laid down shortly after the Big Bang. It is a passive journey. We do not need to steer. We do not need to burn fuel. The architecture of the universe has already decided the route, and the emptiness behind us ensures we keep moving forward. This interplay between the push of the void and the pull of the attractor creates a velocity that is unique to our corner of space. It helps astronomers understand why our local group of galaxies is moving at such a specific speed, 600 kilometers per second, a speed that cannot be explained by the mass of the Great Attractor alone. We needed the push. We needed the emptiness to propel us. So if you feel small, or if the speed of this journey feels overwhelming, remember that we are being assisted. The darkness behind us is not chasing us, it is releasing us. It is letting us go, allowing us to fall freely toward the gathering light of the superclusters ahead. We are drifting away from the lonely spaces, carried by a current that spans hundreds of millions of light years, moving from the empty silence into the crowded, glowing harbor of the heavy universe. Strategy block, audience phrases used: the void, data point, quiet chaos, cosmic cage, viral hooks, the paradox of pushing nothingness, the wind at your back, reframe, production script. But gravity, we have learned, is not just a rope that pulls, it is also a slope that tilts. For decades, astronomers struggled with a simple discrepancy in the data, a mathematical gap that refused to close. The Great Attractor is massive, containing the gravitational weight of quadrillions of suns. Yet even this immense mass is not enough to explain the sheer speed at which our galaxy is moving. The velocity is too high. The numbers do not balance. If gravity were only a pull from the front, we should be drifting much slower than we are. This suggests that half the picture was missing. We were staring so intently at the destination that we forgot to look at the departure point. Behind us, in the direction directly opposite to the Great Attractor, lies a region of space that is functionally empty. It is a vast, hollow sphere of darkness where galaxies are scarce and the usual web of matter is stretched thin. Astronomers call this region the dipole repeller. It sounds like a machine, or perhaps a barrier, but the reality is far more peaceful. It is not an object that exerts force. It is a vacuum of influence. In a universe where gravity is a constant heavy presence, the dipole repeller is a clearing, a place where the cosmic grip is loosened. To understand how emptiness can push a galaxy, we must change how we view the vacuum. We often think of space as a flat, static stage, but it is more like a crowded room. If you are standing in a crowd and everyone pushes you toward the east, you will move east. But if the people to the west suddenly step back, creating an open space, you will move east even faster. Not because the east is pulling harder, but because the resistance from the west has vanished. This is the invisible mechanic of our journey. The Great Attractor pulls us forward with its gravity, while the dipole repeller fails to hold us back. The result is a net acceleration, a sensation of being unmoored. It acts like a wind at our backs. You might imagine it as a gentle hand, resting on the shoulder of the Milky Way, guiding us out of the lonely sectors and toward the warmth of the superclusters. This interaction creates a cosmic flow, a river of galaxies streaming away from the void and toward the dense basins of attraction. We are surfing a wave created by the difference between the nothingness behind us and the everything ahead of us. This void is vast, spanning hundreds of millions of light years of quiet space. To cross it would take eons, yet its very emptiness is what gives us our momentum. Without this silence behind us, we might be stagnant, drifting aimlessly in the dark. Instead, we have direction. We have a trajectory. We are leaving the void not because we are fleeing a danger, but because the universe is seeking equilibrium. Matter flows from the low-density regions to the high-density regions, just as water runs off a high mountain slope to settle in the deep, calm valley below. It is a reminder that in the cosmos, even emptiness has power. The absence of stars is just as important as their presence. This repeller helps astronomers understand that our galaxy is not just falling, it is being escorted. We are caught in a current that spans the observable universe, a flow that ensures we do not remain isolated in the deep. The push is silent, constant, and incredibly slow, operating on timescales that make a human life feel like a single breath, but it is there. If you could feel the motion of the Earth not just around the sun but through the fabric of the universe itself, you would feel this gentle pressure, a subtle acceleration that tells us we are going home. As we drift further from this region of avoidance, the view ahead begins to change. The scattered points of light that mark the boundaries of our local group begin to thicken, merging into a structure that defies our traditional definitions of geography. We are entering the influence of something far larger than a single attractor. We are entering the basin of a continent in the sky. Strategy block. Audience phrases used. Data point. Deep time. The void. Cosmic ocean. Viral hooks. The Russian doll universe. Structure behind a structure. Cosmic vertigo. Shapley scale. Production script. But as we drift closer to what we thought was the center, the map begins to shift again. For decades, astronomers believed that the Great Attractor was the final destination, the bottom of the cosmic drain where all rivers eventually meet. We built our models around this assumption, placing the Great Attractor at the heart of our local universe. But as our vision improved, peering deeper into the zone of avoidance and past the interference of dust and gas, we realized that the Great Attractor is not a harbor. It is merely a bend in the river. Looming behind it, 650 million light-years further into the deep, lies the true giant. It is known as the Shapley supercluster. It is a structure so massive that it makes the Great Attractor look like a small tributary feeding into a vast open ocean. If the Great Attractor is a hill that we are rolling down, then the Shapley concentration is the mountain range standing silently behind it, casting a shadow of gravity that stretches across half the visible universe. It is a structure behind a structure, a mystery behind a mystery. Layers of gravity folding over one another like sheets of silk, distinct yet woven together into a single continuous fabric. We are not just falling toward one point, we are caught in a cascading flow where smaller basins empty into larger ones, and the current grows wider and deeper the further out we look. Here we stop measuring speed in kilometers per second. The numbers become too large, too abstract to hold any real meaning for us. Instead, we simply feel the weight. We are falling further. We are drifting deeper. The urgency of the journey fades, replaced by the realization of the scale. The Shapley supercluster contains the mass of tens of thousands of Milky Ways, a density of matter that bends the shape of space so profoundly. Just as rain falling on a continental divide must eventually find the sea, our galaxy is sliding down the gravitational slope of Laniakea, only to find that Laniakea itself is sliding toward Shapley. We are a data point within a cluster, within a supercluster, within a flow that encompasses hundreds of millions of light years, and in this vastness, the motion feels less like a fall and more like a suspension. To understand this scale, we must change how we view the void. It is not empty space separating these massive objects. It is the medium through which they communicate. The gravity of Shapley reaches out across the silence, a gentle, invisible hand that has been guiding the motion of our galaxy since before the Earth was born. It does not pull with violence. It pulls with patience. It is a reminder that in the cosmos, the largest forces are often the quietest, operating on timescales that make our entire human history seem like a single breath in the night. As we look toward this distant concentration, the individual galaxies begin to blur. At this distance, we no longer see spiral arms or burning stars. We see only a glow, a diffuse light that marks the presence of the largest concentration of matter in our local universe. It is the ocean beyond the river, the deep water where the currents finally slow down. Strategy block. Audience phrases used: quiet chaos, cosmic cage, deep time, drift, comforting darkness, viral hooks, cosmic vertigo, density of galaxy, domestic anchor, city lights versus rural dark, production script. As we drift deeper into this gravitational valley, the scenery begins to change. We are leaving the open, empty plains of the cosmic void and entering a region of immense density, a place where the universe feels less like a vacuum and more like a thick, luminous fog. This is the Norma cluster. To astronomers, it is known as Abell 3627, a massive accumulation of galaxies that sits at the very heart of the Great Attractor. If the Laniakea supercluster is a watershed, and the flow of galaxies is a river, then the Norma cluster is the delta, the gathering place where the currents meet and the waters deepen. You may notice that the darkness here is different. In the sparse regions of space we left behind, galaxies were lonely islands, separated by millions of light years of silent nothingness. But here, the distance between worlds shrinks. The galaxies are no longer isolated points of light. They are neighbors, crowded together in a gravitational embrace that has lasted for billions of years. It is similar to flying over a continent at night. You pass over miles of dark, rural silence, only to suddenly find yourself above the sprawling, interconnected web of a megacity. In this region, the galaxies are packed so closely that they share their halos, creating a continuous mist of stars that bridges the gaps between worlds, weaving a tapestry of light that stretches for millions of light years. It is a place of quiet chaos. To our primitive eyes, a cluster of this magnitude might look like a violent storm, a collision of worlds where structure is torn apart. But space does not move at the speed of human anxiety. Here, the interactions are slow, graceful, and silent. Helps astronomers understand that when galaxies meet in a cluster like Norma, they do not crash into each other like cars on a highway. They pass through one another like ghosts. The stars within them are so far apart that they rarely collide. Instead, the galaxies simply slide together, their shapes distorting and stretching under the influence of their combined gravity. It is a dance that takes eons to complete. A spiral arm might be pulled loose, drifting away to form a bridge of starlight connecting two ancient systems. Or a cloud of gas might be stripped away, glowing hot as it settles into the space between the galaxies. This is the cosmic cage that holds our local universe together. The gravity here is so intense that it bends the path of light itself, creating a lens that distorts the view of whatever lies behind it. And yet, for decades, we did not know this massive structure existed. It was hidden from us, obscured by the dust of our own Milky Way. We were like sailors on a ship, unable to see the massive continent ahead because of the fog on our own deck. It was only when we learned to look with radio eyes that could see through the dust, that the Norma cluster revealed itself. It is strange to think that this massive silent swarm of galaxies has been pulling on us for our entire existence. Every star in our night sky, every planet, and every atom in your body is feeling the faint, persistent tug of this cluster. We are falling toward it, caught in a slide that began before the Earth was formed. But because the universe is expanding, stretching the space between us and Norma, we will likely never arrive. We are running on a treadmill, moving at millions of miles per hour, yet staying in the same relative place in the cosmic web. There is a comfort in this suspension. We are not drifting aimlessly. We are held in a balance between the expansion that pushes us apart and the gravity that pulls us together. The Norma cluster is not a monster waiting to devour us. It is simply the anchor of our local reality, a heavy, silent center that gives structure to the flow of Laniakea. As we hover here, watching the slow-motion ballet of 1,000 galaxies, the sense of urgency fades. The motion is so slow that it looks like stillness. It is a reminder that the universe operates on a clock that we cannot read, ticking in intervals of hundreds of millions of years. What looks like a static picture to us is actually a single frame in a movie that has been playing since the beginning of time. But to understand this scale, we must stop thinking in miles and start thinking in eons. Stredici block, audience phrases used: deep time, the ocean, drift, comforting darkness, eternal silence, viral hooks, cosmic vertigo, time scale, the safe void, production script, chapter 7, the speed of stillness. If you were to float outside the galaxy and watch this journey unfold, you would not see motion in the way you understand it on Earth. You would see a tableau of light, frozen in the amber of deep time. The speeds involved are tremendous, yet the distances are so vast that the movement renders itself invisible to the human eye. It is a phenomenon we might call the speed of stillness. You may notice that when you watch a cloud drift across the horizon or observe the hour hand of a clock, the change happens without a sense of urgency. The Great Attractor operates on this same principle, but magnified by a factor of billions. We are moving at hundreds of miles per second, yet if you looked at the night sky 10,000 years from now, the stars would appear almost exactly where they are tonight. This is the comfort of the cosmic scale. It protects us from the chaos of rapid change, wrapping our entire civilization in a blanket of slow, enduring stability. To reach the center of this gravitational valley would require a span of time that makes the age of the Earth seem like a single heart. It is a journey calculated not in years, but in eras. And this leads us to a realization that is not frightening, but deeply peaceful. We may never actually arrive. There is another force at play in the quiet dark, a gentle stretching of the universe known as expansion. While gravity pulls us toward the Great Attractor, the space between the galaxies is slowly widening, like a calm ocean expanding between two drifting rafts. It is a delicate balance between the pull of the harbor and the widening of the sea. Some astronomers believe that this expansion will eventually become faster than the flow itself. The horizon we are swimming toward may gently recede, moving away from us just as fast as we move toward it. In a human life, a destination that moves away is a source of frustration. But here, in the deep sleep of the universe, it is a form of eternal purpose. It means that the journey is not about the arrival. It is about the suspension. We are not racing to a finish line where everything ends. We are simply drifting in a current that will last forever. You can stop worrying about the destination, because the universe has removed the pressure of ever needing to get there. Think of it as being on a boat in the middle of a boundless sea, where the water is calm and the stars are bright. You are not rowing. You are not steering. You are simply being carried by a tide that is ancient and sure. The Great Attractor is not a drain that we are falling into. It is a lighthouse on a distant shore, guiding the flow of the local universe, giving direction to the dust and the stars. Even if we never touch the land, this state of permanent travel creates a kind of forever that is difficult for the mind to grasp, but easy for the spirit to rest in. It allows the galaxies to dance without colliding, to flow without crashing. It creates a cosmos that is not defined by violent impacts, but by a long, silent waltz through the void. You are part of this waltz. Your body, resting now, is made of the same atoms that are caught in this gravitational stream. You are traveling through the dark at incredible speeds, yet you feel nothing but the stillness of the room around you. This is the paradox of our existence. We are hurtling through the infinite, yet we are perfectly safe, cradled in the quiet center of the flow. As we drift deeper into this idea, the urgency of the pull begins to fade. The numbers and the velocities dissolve, leaving only the sensation of weightlessness. The river is wide, the current is slow, and you have all the time in the world.